I'm very excited to be here with .NET C# community at Portland. I'm going to talk about gRPC, a high-performance, open-source, universal RPC framework. I'm going to show you how to write gRPC services and clients in C# and .NET. Hope you enjoy. I'm Deren, a senior software at the Cloud Shop team at Google Cloud Platform. My team is dedicated to bring tools, libraries, and solutions for .NET C# developers on Google Cloud Platform. You're welcome to send questions, feedback to Deren Liao at google.com. I will try my best to answer you if I can. So at the agenda, I'm going to quickly go through concepts of RPC. Firstly, I'll talk about basics of gRPC. With that, I'll do a quick demo to show how simple it is to implement gRPC service and clients. gRPC benefits. This is to hopefully it will answer your question about what makes gRPC a competitive choice. In the end, I think you will spend some time to play with it, to get familiar with it, and make the decision if it's the right choice for your next project. If we have more time, I'll show you a bidirectional streaming gRPC sample, a simple group chat app. Introduction. This is the code sample for regular procedure call. We all know this very well. And from Wikipedia, this is about remote procedure call. The programmer writes essentially the same code whether the subroutine is local to the executing program or remote. Yeah, you can read all of them if you are interested. Go to Wikipedia. And this is a diagram shows how an RPC client interacts with an RPC service. The client runs on a computer, mobile device, or any IoT devices. There are many different ways for clients to talk to server. RPC is one way that makes the task simple and standardize it. So why not REST? For simple services, HTTP REST is probably enough. It has get, post, put, delete, and are rich enough. And REST semantics are well understood. For more complex services, with efficiency is important. Example like if it's domain-specific, imagine a bank transfer scenario. And if you like more strongly typed experience with stubs, and if you want to choose efficiency with HTTP2 protocol buffer, and gRPC might be the choice for you. What is gRPC? Stands for gRPC Remote Procedure Calls, a high-performance, open-source, general-purpose, standard-based, feature-rich RPC framework. Open-source version of Stubby RPC used in Google. Stubby is widely used at Google for internal services, user-facing services, from internet products to software-defined network products, and on and on. It's actively developed and production-ready. It continuously releases with new features, bug fixes. It's production-ready. Many companies are using gRPC, Square, Cisco, Google, Docker, Arista, Netflix. There is a long list of companies that has been using gRPC. It's a mature framework already. Motivations and design principles. You can go to grpc.io blog principles to read the full text of all these design principles, motivations. I'm not going to go through all of them. Yeah. how does it work? It a high-level service definition to describe the API using protocol buffers. You create service definition using protocol buffers. Generate the client and the server code from the protocol buffer API definition in more than 10 languages. It's efficient in serialization with protocol buffers and the connections with HTTP2. It has flexible connection options, either unary server-side streaming, client-side streaming, bidirectional streaming, and authentication options. You can choose SSL, TLS, token-based authentication. At high level, the diagram showcases the loose coupling service-oriented architecture. With SOA, you can patch, upgrade each component independently. And gRPC is especially useful in a service-oriented architecture system. Okay, back. Show me the code. It takes 4 easy steps to implement gRPC services and clients. Let's go through them one by one. Step 1, create the API definition in service in protocol buffer. Please notice it is the most simple service definition protocol buffer language. Define a service using keywords service and use the RPC keywords to define an API. The API name here is greeting. It takes a hello request as input, returns a hello response as an output. The input and output both are defined as messages. A message can contain fields of basic types, and it can also contain other messages or arrays of data. Step 2, generate client and server stubs. Generate client and server code to extend from using Proto3 compiler. The Proto-C tool are the tools to generating the code. Are available for all supported languages. For .NET, you download the gRPC.tools NuGet package, and it has the Proto-C tool. Later, I will show you the command to generate C# code from the Proto-C tool. Step 3, create the server. Create a server implementing extending from generated base class. Create a class server with port and using the service implementation and start the server. That's for creating the server. Create the client, create a channel, create a blocking or non-blocking client stub with the channel. Create a request, send the request, get the response. Okay, demo. Let's go to C# code. Firstly, I'm going to this is a greeter server client sample. It's simply client send a message to the server replies a message back. The service definition. I didn't see. Okay. Project, duplicate. Okay, good. The first syntax, Proto3, that is the current supported version, version 3. Package defines the namespace of this service and messages. Enum defines the hello request is defined as its message. Hello response is the return value of the service. And these RPC keywords define an API greeting, and that's the proto definition of the API. And the second step is to generate the code. As I mentioned, it can be downloaded from a NuGet package. And here, I already have it. That's the commands. It actually takes 2 commands to generate 2 files from the service definition file. So generate. Then we should be able to see the files. Here, I just generated them, files. The first generated file are for the message definitions. It has the message definition together with some supporting methods like copy, clone, access array fields, something like that. The second file for the service and the client stuff, like the service base, service client, and some class used by the server. So with that, I'd like to mention, so to build the gRPC service codes, need to add a NuGet package, google.protobuf, gRPC core. This is optional, that's just for the tools. And then another system interactive.async. Okay, I'm going to be able to build it. Okay, yeah, that's for the generated code, step 2. Step 3 is to implement this service by extending the generated service code. That's greeting service base was just generated. And this is the service we are going to implement. And then this is the API. By override the greeting API, here we put the code, our own code here, by sending back a hello response, adding a hello back. That's for implementing the service. And to start the server, to define your host port, create a server object, tell it that what service we are going to host. That's the service we just defined, and the server part, and then the authentication way, and start the server. That's for creating the server. And creating the client is even easier. Just tell it what the endpoint, create the channel with the host port and the authentication way. Create a client with the channel. Create the request message. Here is the message, whatever you want to put, and send it to the server, and you get the response. So to prove that I'm not cheating, let's quickly run it. And so let's start it. Run here. Okay, yeah. When the client starts, it hits the service implementation. And go. Yeah, so the server says it's received and sent the message back, and then the client received it. Received the response too. Okay, that's the get back to the slides. Okay. Oops. Back. Okay. With that, let's talk about gRPC benefits. The bulletin points are in a high level. These are the main benefits using gRPC. HTTP2, low latency transport of contents, proto buffers, or even you can choose a bond with efficient serialization. It has multiple language support, and there are flexible connection options, unary server, client, bidirectional streaming. Let's talk about HTTP2. So, the first official HTTP 1.1 standard was officially released in January 1997, roughly 6 months after the publication of HTTP 1.0. And billions of devices of all shapes and sizes, from desktop computers to the tiny web devices in our pockets, speak HTTP every day to deliver news, videos, and millions of other web applications. HTTP 1.1 has been there for a long time, and let's take a close look on what can be improved. For HTTP 1, the parallelism is limited. Each HTTP connection requires a TCP connection. The number of parallel HTTP requests requires the same number of TCP connections. In HTTP 1.0, there is even no pipeline support. You can only send a new request after receiving the responses of previous request. In HTTP 1.1, HTTP pipelining is introduced to address the problem. HTTP pipelining is a technique in which multiple HTTP requests are sent on a single TCP connection without waiting for the corresponding responses. However, this sounds matter. The limitation is the server must send its responses in the same order that the requests were received. So the entire connection remains first in, first out. HLL blocking can occur. And okay. In 2009, somebody started to think of ways to tackle problems. They started a group at Google and gave it a name SPDY, and it speaks as speedy. The goal was to gain speed. Speedy achieves reduced latency through compression, multiplexing, and prioritization. Depends on combination of networks and website deployment conditions. In February 2015, Google announced its plan to remove support for Speedy and move in favor of HTTP2. And HTTP2, Speedy 2 was chosen as the basis of HTTP2. HTTP2 released in 2015 extended the semantics of HTTP1, improved end-user perceived latency, address the head override blocking, not require multiple connections, minimize protocol overhead. And it used single TCP connection, no head override blocking. It used binary framing instead of text. request stream, it uses header compression. Comparing here, compare the HTTP1 and HTTP2, their packages. HTTP2 binary framing. Stream is a bidirectional flow of bytes, and a message is a complete sequence of frames. And the frame is the smallest unit of communication in HTTP2. This is how the multiplexing works. Interleave multiple requests and responses in parallel without blocking on any one. And you can see the stream 1 data can be sent after stream 3 data. When there is HLL blocking, it must wait. Stream 3 must wait. And using a single TCP connection. HPAC, header compression for HTTP2. And for most requests, like request number 1 and number 2, they have exactly same headers. And HTTP2 will only send the delta with indexes for already seen values. And this is the HTTP2 demo.io is a website you can go to check out the performance differences. It's quite impressive. Google Cloud PubSub service exposes both REST API and gRPC API. They did an analysis. It has 3 times increase in throughput and 11 times difference per CPU. That's performance improvement is significant. gRPC has multiple language support. It supports Java, Go, C, C++, C#, Node.js, PHP, Ruby, Python, Objective-C, platform, macOS, Linux, Windows, Android, iOS, all the platforms, connection options. Okay. Unary RPCs where the client sends a single request to the server and it gets a single response back, just like a normal function call. And a server streaming, the client sends a request to the server and it gets a stream to read a sequence of messages back. The client reads from the return stream until there are no more messages. Client streaming, client sends a sequence of messages to the server using a provider stream. Once the client has finished writing the message, it waits for the server to read them and return its responses. And bidirectional streaming, both sides send a sequence of messages using a read-write stream. The 2 streams operate independently. The order of messages in each stream is preserved. Here, I'm going to demo a chat app using gRPC streaming. So firstly, I'm show you. Do I need to switch again? Duplicate. Okay. I have a chat app server. Okay. Chat. This chat app, each client can send a number of requests to the server. And the server sends all the messages received from clients to all the clients. And this, like, show the idea. Hello, send, say, Tony, send, world, send, and say somebody else, say, have a nice day, send, and that's how the app would be. Then with that, I'm going to show you the code, how to make it work. So you can achieve the same results with many different ways. gRPC will make tasks easy and efficient, reliable. And the chat app. So firstly, let me close all the documents. The definition of this chat app API, it takes the chat message, returns a message back. That's the service definition. And the chat server, same thing. This API definition is slightly different. Forgot to mention. To make the stream, there is a slight difference. You declare it as stream input, stream output. And the service implementation is slightly different. Look at the API definition. It has async stream reader, server stream writer. And the server, the API, use a while loop, wait for messages. When it gets a message, it enters the loop, and it gets the message with .current, and it sends messages back to all the clients here. For each of the clients, send the message back. And the client's code. So the client's code, it creates a channel, creates the services the client stop, and open a connection to the server. The same connection start at when the client starts. It creates an async task, stay in background, and to receive all the messages from the service. It uses the similar syntax, using a while loop to wait for the messages from server. And when it gets a message, it uses the .current to get the message and display it. And when user clicks the send button using the same client object, it can send messages continuously to the server. And that's the client code. So in the end, you always use on-closing. We use complete async to shut the connection. That's okay. Let's get back to us. Summary: gRPC is HTTP2 protobuf, or even bond if you like, and it's high performance, open source, actively developed, and has more than 10 languages support, and it takes 4 easy steps to implement a server and a client, and easy to create streaming connections. And with that, I think, with that, I conclude today's talk, and thanks for listening, and wish you have a wonderful evening.